children, we completed sample paper for the first part, that is 11 questions we have solved. Now 12th question onwards. The following are the runs made by 18 players in one day cricket match. 29, 28, 45, 99, 3, 46, 80, 37, 24, 73, 122, 46, 27, 16, 7, 3. Find the median and mode of the data. Median means what is the step we have to go for? Ascending order. So let us see the solution now. So in the ascending order, 0, 3 times, 7 2 times, 8 16, 24 27, 28, 45, 46 2 times, 73, 79, 99, 122. Now number of observation, if you count, it is 18 because 18 players data is given, even number. So what is the formula we have? Median equal to n by 2 n by 2 plus n by 2 plus 1th observation's average. That means n by 2 means it is n by 2 plus 1 is 9th observation, then 10th observations divided by 2. So if you check that one, 3 6 7 8 9, that is 24 and 27. So 24 27 add and divided by 2, it is equal to 25.5 runs. Now mode also it is asked in the question. Mode is 3 only because it is repeated 3 times. So the most repeated score. Question number 13. In triangle PQR, S and T are the points on the sides PQ and PR respectively. Area of the triangle SQO equal to area of the triangle TQR. Show that SQRT is a trapezium. In triangle PQR, this time diagram is given. So we will complete first given and to prove only. So given area of the triangle SQO equal to area of the triangle TQR to prove SQRT is a trapezium. So now let us see the proof. SQO equal to area of the TQR, that is a given part for us. Now listen, this is given. That means if you check the figure, SQO here. And similarly TOR only. TOR it is O only. Okay, next what is the next part? We should get the triangle SQR and TQR because it's a area the parallelogram chapter 9 only. We need the triangle which is between these two lines and also same base. So QR as a base, if you keep your fingers on QR, what is the triangle we are getting? SQR is getting. But in the question it is given that this equal to this, the shaded part like this, right? So this is less for becoming the triangle SQR. So this dotted part, that OQR, I'm adding to both the triangles. So first triangle is which one? SQO. I'm adding OQR. So what is the result we are getting? SQR. We are getting similarly. It is TOR only and adding this dotted part. So what is the dotted part? OQR. So it is TOR. In the question also you should correct it is TOR only. Next we are adding this dotted portion. So again you keep the fingers on QR. What will get? You are getting the triangle TQR. So we got the triangle SQR and TQR by adding QOR on both the sides. So that means these two triangles, if you check this one, they are on the same base QR and the same lines, which is the they are having equal areas. Now we are having converse theorem only. They are equal area. So if they are having the same base and they are having equal area, then they must lie between the same parallels. Which are the parallels? ST and QR. Definitely QR, the base is one of the line, other line will be ST. So ST parallel to QR. STRQ is the trapezium. What is the definition for a trapezium? One pair of opposite sides are parallel in a quadrilateral. Now we got. For understanding this one, this year it is difficult because the chapter is deleted. Question number 14. Draw a line segment AB equal to 12 centimeter. I buy the ruler and the compass. Obtain a line segment of length 1 by 4th of AB. Write the steps of constructions. So the perpendicular bisector line segment property we have to use. Then here we have to mark 1 by 4th of AB. Let us see the steps of construction and diagram. Steps. Draw AB equal to 12 centimeter, perpendicular bisector of AB. Then you will get it is divided into two equal parts, each is equal to 6. Then again this 6 to be divided by perpendicular bisector, it will become 3 centimeter. So after that, what is the statement we had write? Each part is equal to 1 by 4th of AB. If you can verify 1 by 4 into 12, that is equal to 3 centimeter. Now let us see the construction. So what is the total length of AB? 12. It is divided into two equal parts. That means up to here it is 12 centimeter. Again, 6 centimeter. For total is 12. Each part it is equal to 6. Right? Now what is the next step? Again we are doing the perpendicular bisector. That means AM equal to 3. That is called 1/4 of AB. That means each part like this. So just we have to draw the perpendicular bisector only. So each part should explain as 1 by 4th of AB and its length is equal to 3 centimeter. Question number 15. In the given figure, O is the center of the circle. If the diameter AD bisects BOC, prove that angle BOD and OBC are complementary angles. So what is given in the question? O is the center of the circle, then angle BOD, because it's bisects, so angle BOD equal to DOC. These two angles are equal. Now what is to be proved? We have to prove that angle BOD and OBC are complementary angles. Angle BOD plus angle OBC equal to 90 degree. Now proof. What is the proof? OB equal to OC, right? So that means angle OBC equal to OCB. That means base angles are equal. What is the reason? Angle opposite to equal sides, the first part, right? Now in triangle BOC, if we are taking angle OBC plus OCB plus angle BOC equal to 180 degree angle sum property. Now we know that OBC and OCB are equal. OBC and OCB are equal means it is 2 times of OBC, because we need to prove that OBC and BOD are complementary angles. So instead of OBC and OCB, what I can write? 2 times of OBC. Now BOC, that is the whole angle, it is divided into 2 equal parts. Actually the question is asked for BOD, so these 2 angles we are writing as 2 times of BOD. So 2 times of OBC plus 2 times of BOD equal to 180 degree. Now 2 cancel means what will get? Angle OBC plus angle BOD equal to 90 degree. That means they are complementary angles. So hence proved the result. Points X and Y lie on the opposite side of ABCD respectively of a parallelogram ABCD such that AX equal to CY. Show that AC and XY bisect each other. This particular question, no diagram is given. So from the diagram onwards we have to start this question. So first I will complete given to prove only. So with the 2 points we are having, what is that? ABCD is a parallelogram, AX equal to CY. To prove AC and XY are bisect each other, try to draw the diagram first. So ABCD is a parallelogram, X and Y are on the points on the side AB and CD respectively. So we are writing, now it is given that AX equal to CY. So I already marked here AX and CY are equal. Now AC, that means diagonal AC, and XY is one only diagonal, other one is not a diagonal. XY bisect each other we should take. So let us see that one. These 2 triangles we are having now. In AOX and COY we are taking the angles. Angle 1 and 2 I have marked here, that is a vertically opposite angles, and it's a parallelogram. So it is a parallelogram. So interior angles are also equal only. So angle 3 equal to angle 4. What is the reason? Alternate interior angle, which is the transversal there xy. Now it is also given that ax equal to cy. So ax equal to cy also we have taken. Now triangle AOX is congruent to triangle COY. Triangle AOX is congruent to triangle COY only. What is the criteria? Two angles and one side. So yes, S is not included here. So by this what we can write? AO equal to CO CPCT, again OX equal to OY, another CPCT. This shows that O is the midpoint. Check that AO equal to OC, O is the midpoint there. Again OX equal to OY, again O is the midpoint. That means AC and XY are bisect each other, right? By the point O. It is divided into equal parts only, you can see that. So what is the question here? It is given that parallelogram. In that parallelogram, it's clearly instructed that x is on the side AB and y is on the side CD, such that AX equal to CY. Now the diagram is not given, so we should do according to the questions only. Now we are getting the two triangles by joining the x and y. So the two triangles, what we are getting? Two angles, one side are equal. So AAS criteria, these two triangles are congruent. By the result of CPCT, what we can write? AO equal to CO, OX equal to OY. That shows that AC and XY bisect each other, hence proved. ABCD is a parallelogram and Q is any point on the side AD. If area QBC is 10 cm square, find area of the triangle QAB plus area of the triangle QDC. So this is the question is given, question number 17 only, again chapter 9 only question. So we will complete what is given in to prove the part of the questions. Given ABCD is a parallelogram, Q is any point on AD, area QBC equal to 10 cm square. To find area QAB plus area QDC. Now let us see the proof. Proof. Area QBC. First you will see the diagram. ABCD is a parallelogram. Q is a point on the AD. It's also not given in the question. We have to do the diagram only. So when a triangle and a parallelogram lies between the same base and between these two parallels, then area of the triangle equal to half of the area of the parallelogram. There is a theorem like this in chapter 9. So area QBC equal to half into area of the parallelogram ABCD. Now what we can write? Area ABCD means this is the first part. What is the first part? Triangle and the parallelogram. If they are lies on the same base and between the same parallels, then area of the triangle equal to half the area of the parallelogram. So we have written area of the triangle QBC equal to half into area of the parallelogram ABCD. Now what is see the figure? If you can write, we can write area ABCD means three parts. What is the first part? Area QAB, right? Next area QBC, second part. Now third part is area QCD, right? But we already know that area of the QBC equal to half into area of the parallelogram ABCD by the point number 1. Now what is the remaining part? 1 and 3. If it is half of the area of the parallelogram, then the remaining area is also equal to half the area of the parallelogram only. That means what we can write? Area ABCD. This I am taking to right side. Area of the ABCD minus half into area of the parallelogram ABCD equal to QAB plus QCD. That means half into area of the parallelogram ABCD equal to QAB plus QCD. So if you take a single triangle QBC and the remaining two triangles, which are the QAB and QCD, both are equal to this sum, and a single triangle QBC equal to half of the area of the parallelogram ABCD. So it is already given that QBC's area is 10 cm square. That means area of the QBC is already equal to sum of the areas of QAB plus QCD. That means it is equal to 10 cm square. So the answer is 10 cm square. Question number 18. A heap of paddy is in the form of a cone whose radius is 2.1 meter and height is 2.8 meter. If the heap is to be covered exactly by a canvas to protect it from the rain, find the area of the canvas required. That means a heap of paddy is in the form of the cone only. Radius and the height is given. What is the radius? 2.1 and the height is 2.8. The heap is covered by the canvas and find the area of the canvas required. Let us see the solution now. So the diagram is like this. Radius is 2.1, height is 2.8. So we must write like this: r equal to 2.1 meter, h equal to 2.8 meter. If r and h is given, so what we can calculate? L. L, what is the formula? Square root of h square plus r square. Substitute this one. H is 2.8 whole square and r is 2.1 whole square. And if you simplify, we will get 3.5 meter. That means slant height L equal to 3.5 meter. Now actually the question is asked for canvas required. That is, with respect to the cone, it is a CSA only. What is the formula for CSA of the cone? Pi RL. So substitute 22 by 7 into 2.1 into 3.5. If you simplify, you will get 23.1 meter square. So the area canvas required is the CSA of the cone, which is equal to 23.1 meter square. With this, today's video I am winding up. Thank you.